And we are recording. Okay, so section 6.2 and 6.3, we're going to cover both of those today. Trig functions and identities. And remember, everything we're dealing with, sine, cosine, tangent, that kind of stuff, that's what we're dealing with. So, reference angle. In your notes from yesterday, one of the things you talked about were angles that were coterminal. The reference angle is the positive acute angle from the terminal side to the x-axis. What it deals with is that any angle can be reduced if it's more than 2 pi or less than 0 pi, can be reduced to something between 0 and 2 pi, and then we can find the angles from it. Okay, so if you think about what you were watching in the video yesterday, we talked about angles, and every angle in terms of radians can be reduced to either something between 0 and 2 pi, and that's what you want to do. And the reference angle is that equivalent angle. Okay. The signs of the trig functions. This is where it comes from. Start in quarter 1 and go counterclockwise. Which ones are positive, which ones are negative? Actually, these ones are all positive. I will not share you the mnemonic device for remembering which ones are which. I don't particularly like it. There's a very common one. So in the first quadrant, all trig functions are positive. In the second quadrant, the sign is positive, which would mean the cosine and the tangent. We're only talking about sine, cosine, and tangent at this point. And yes, there are other trig functions. You will learn them today. Okay. In quadrant 3, the tangent's positive because sine and cosine are both negative. And in quadrant 4, and you know how to count your quadrants, right? 1, 2, 3, 4. Everything always goes counterclockwise. Everything goes counterclockwise. In quadrant 4, the cosine's positive, the other 2 are negative. So, consider a point P in a plane. Can you find the trig function of the angle formed by P using the coordinates of P? Yes, you can. You can do this. So what they're talking about, if this is point P, and I've got an angle theta that gives me that angle, can I find the sine and cosine, and therefore anything else of that from that coordinate point? I can. Okay. So if I have, that is my angle, this is my y coordinate, this is my x coordinate. Oh, yeah. You're welcome. So you can take a coordinate value, make it a triangle, and use your right triangle trig. Okay. Now I'm missing something, aren't I? I need something else in order to be able to come up with my sine and my cosine. What part of the triangle don't I have? I don't have the hypotenuse. But remember, this is a point, we want to think about this as a point being on a circle. So that's a point on a circle. What's the distance from the center of the circle to the outer edge of the circle? The radius, r. And we can find r using Pythagorean theorem. X squared plus y squared equals r squared. Okay. Now, what are the functions we're dealing with here? We're dealing with the sine of theta. And that is how you say it. You say theta. That is what that angle is. That's the most common variable for angles is theta. Okay. So the sine of theta would be y over r. The cosine of theta would be x over r. And the tangent of theta would be y over x. So if we have an XY coordinate that is considered an angle that is, any XY coordinate that is on that side of that angle, we can find the sine, cosine, and tangent for that angle using that XY coordinate. And then once again, how do we find R? X squared plus Y squared equals R squared. Not on that one. You will in a minute. So find the sine, cosine, and tangent of an angle at the terminal through the side point. So first thing we need to do is say, all right, we've got an XY axis. Where is the point 512 at? It's somewhere up here, right? So I have the line going down here. My X is 5. My Y is 12. What is my R? This is a Pythagorean triple. Just like the 3, 4, 5 right triangle, this is 5, 12, 13. Certain ones you should start to learn. 3, 4, 5, and all the multiples of that. 5, 12, 13 is also a very common one. So the radius on here, R, is 13. So what's my sine? And I'll call this angle theta in here. It would be 12 over 13. What would be the cosine? 5 over 13. And then the tangent would be 12/5. Not too hard, right? Okay. For the next one, do the same thing. Plot the point, draw the angle. That's your first step. So -3, -2, it's somewhere over here. What's my angle measurement? And I'm not looking for the degree or the radians, but what am I talking about for my angle here? My angle is not just this little space here. That's my angle theta that I'm talking about. You always start at the positive x-axis and go around counterclockwise to get your angle. So that's my angle I'm talking about. That's my angle theta. That's it. Yeah, it just so happens that it's also the same as this angle here for all the values, but that's okay. Now the coordinates were -3 on the x, -2 on the y. What's my radius on this one? Square root of what? Square root of 13. R equals square root of 13. And then we want to do sine, cosine, and tangent for those. So the sine of theta would be -2 over root 13, right? But what's wrong with that? Yeah, it's irrational. Well, I should say the denominator is irrational. We need to rationalize our denominator. We're not allowed to have square roots in our denominator. This is a very easy fix to make when all you have is just the square root of something in the denominator. Not a problem. -2 root 13 over 13. That's it. You're multiplying top and bottom by the square root of 13, but that's the pattern to it. And then the cosine would be -3 root 13 over 13. And what's the tangent going to be? It's y over x, right? So it'd be -2 over -3, which would be positive 2/3, because 2 negatives make a positive. 2 wrongs don't make it right, but 2 negatives do make it positive. Okay? Questions so far? Okay, now consider it if it were the unit circle. if instead of just some random value, the coordinate was on the unit circle. Come on. Oh, I hate it when it does that. There it is. If you're on the unit circle, the coordinates are cosine and sine. So if you have a point on the unit circle, the cosine of theta is the x-coordinate. The sine of theta is the y-coordinate. The tangent of theta is the y-coordinate over the x-coordinate. That's what's so awesome about the unit circle. Is the x-y coordinates are all your cosines and sines. Makes it easy. And that's why we're going to do it. And we use the unit circle because, remember, anything can fit on that unit circle because any line that goes out, we can narrow it down and make it smaller because all triangles are similar to some extent. And the unit circle will have, any angle of this measurement will have the same ratio because that's what your sine and cosine are, it's a ratio of the sides. And any triangle with that particular angle measurement, an acute angle measurement, will have the same ratio of sides as similar triangles are. So it doesn't matter how big or small, but if we break it down on the unit circle, that will give us everything. Okay? So you have to remember, the cosine of theta is x. The sine of theta is y, and the tangent of theta is y over x. Okay. So this is a point on the unit circle. 1, 0. What is this point on the unit circle? What are the values of the radians for this one? 2 pi and 0. So this is either 0 radians or 2 pi radians or some variation thereof. Basically any even value of pi. Well, any even integer of pi will give you this one. So what's my cosine? Cosine is 1. Sine of theta is 0, and the tangent is 0 over 1, which is 0. So on the unit circle, the xy coordinates are there. Do B. Yeah, B at do B. So the cosine is negative 1/2. The sine is root 3 over 2. And the tangent would be what? Yeah, which reduces to what? Negative root 3. Remember, all of them are something over 2. So your values of tangent are going to be, the values of your tangent are going to be plus or minus 0, root 3 over 3, 1, or undefined. Those are all the possible values on the unit circle of tangent. Because we're limited on the possible values of sine and cosine, and when we do do the sine over cosine, which is what the tangent is, you're going to get one of those values. It's either going to be 0, 1, 0, 1, root 3 over 3, or undefined, plus or minus. Okay. Okay, find a coterminal angle somewhere between 0 and 2 pi, and find its sine and cosine. Once again, this is where the unit circle comes in handy. So 17 pi over 3. Well, 17 pi over 3, remember we start at 0 and go counterclockwise? Well, that's several times around the circle. I don't want to go several times around the circle. I want to find the angle between 0 and 2 pi that is the equivalent of this one, that is the same as 17 pi over 3. Now, there are a couple of ways to do this. The way that I had you do it for your notes was to subtract 2 pi repeatedly until you got a number between 0 and 2 pi. Now, because this is over 3, I don't want to subtract 2 pi. I want to subtract 6 pi over 3. Why do I want to do 6 pi over 3? Common denominator. It's 2 pi with a common denominator, right? 6 over 3, that's 2. Common denominator. So I would subtract 6 pi over 3. 17 minus 6 is what? 11. So that gives me 11 pi over 3. Well, that doesn't work because that's still more than 2, right? 11's more than twice 3. So what do I need to do? I need to do it again. Subtract 6 pi over 3. So 11 minus 6, that's 5 pi over 3. And now I can find 5 pi over 3. That's here. So this angle to there. And then what are the sine and cosine values, i.e. the x and y coordinates on your unit circle for 5 pi over 3? So the x would be, which is the cosine, would be 1/2. So the cosine of 17 pi over 3 is 1/2, and the sine of 17 pi over 3 is negative root 3 over 2. I need to subtract 2 pi. And 6 pi over 3 is 2 pi with a common denominator. Yeah, common denominator, fractions. Ooh, wait. Oh, good, nobody passed out when I said the word fractions. Okay, 9 pi over 2. Okay, that's actually, there's another way to do this, and this one's actually very easy. Where are your pi over 2 values? Without freaking out, straight up, everywhere around on the tops and bottoms. Your pi over 2's, that's 1/2 pi. 1/2, 1, 3.5, 2, and so on. Here's what you can do if you've got 9 pi over 2. Count your pi over 2's until you come to a stop. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where 9 pi over 2 is. So I count by pi over 2. Pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2. That's what you do. You count by pi's over 2. So I count around because pi over 2, all the over 2's are either straight up or down or sideways this way. Because 1 pi is 2 pi over 2. 2 pi is 4 pi over 2. So I did it that way. So that would be the equivalent of, or I should say the coterminal angle would be pi over 2. And then what are the cosine and sine? Cosine straight up would be 0. Sine would be 1. And the next one's very, very easy. I can tell you what they are but I would still have to figure out plus or minus because everything that's pi over 4 is what? root 2 over 2. Sine and cosine are both root 2 over 2. The thing you have to figure out is, are they going to be positive or negative? Figure it out. Find the coterminal angle. Figure out if they're going to be positive or negative on that one. And there's a couple of ways to do it. Just have to figure out which one's positive, which one's negative. They both are, or neither one of them. That's why I like pi over 4. Anything over 4, something pi over 4, easy to get. It's root 2 over 2. You just have to figure out whether it's positive or negative. Okay. Is 11 more or less than twice 4? More. So what do I need to do? I need to subtract 8 pi over 4, and that gives me 8. 11 minus 8 is 3 pi over 4. And 3 pi over 4 is here, which means that the cosine is negative and the sine is positive. Because the cosine is the x-coordinate, sine is the y-coordinate. Okay? Clear as mud?
Yes.
Questions so far? Yeah, this is going to be a tough chapter because a lot of this stuff is brand spanking new. I need to subtract 2 pi, but I need to have a common denominator. That's why it's 8 over 4, because 8 over 4 is 2. Common denominator. Okay. So, cosine of theta is negative 4/5, and the sine of theta is less than 0. I need to find the value of the sine and the value of the tangent based upon this information. So when I look at this and it says the cosine of theta is negative 4/5, that means we go back to what we were talking about earlier with any point P, being able to find it. I have 2 possibilities for my point P. Because remember, the cosine of an angle is the x value of our coordinate point divided by r. So my x coordinate is going to be negative 4. But there are 2 possibilities that give me an x coordinate of negative 4. I have one here, and I have one here, where this is 5, and that's 5. So the sine is less than 0. Sine is the y-coordinate, right? So where does my y-coordinate have to be? My y-coordinate has to be down here. So this is the point I'm talking about. So I have negative 4 and negative 5, yes.
Wouldn't that be, would that make the cosine positive?
I'm sorry. This is negative 4, that distance here.
Yeah, but like the x and the y values are both negative, right?
Yeah, so what is my x value? What is the cosine? Remember what's the cosine value? The cosine is x over r. And your r is always positive because that's the distance from the center. So r is always positive. The cosine and sine, them being positive and negative, will tell you what quadrant you're in. So they're both negative here because the sine has to be negative and the cosine is negative. This is the place where both the sine and cosine are negative. Now, if this is 4 and this is 5, what's this length here? 3, 3, 4, 5, right triangle. So that means the sine, it would be negative 3 because I'm going down. So the sine of theta is negative 3/5. And the tangent of theta would be negative 3/4, which is 3/4, x over y.
But you knew that the 5 goes down because the sine is less than 0.
Okay, next one's a little more difficult. We have an angle beta. And the sine of beta is 2/3. So that means my y-coordinate is 2 and my radius is 3. So I'm looking at this. I have two possibilities. I have this point here or this point here. Those are my two possibilities. My radius out is 3, my y-coordinate is 2. Those are my two possibilities. I need to narrow it down. My other information tells me that the tangent is less than 0. The tangent is negative. Which would make it what? It would be over on this one over here. To your left. Okay. Because over here, what's my x-coordinate? My x-coordinate would be positive. If it were this point here, my x-coordinate would be positive. Which means I'd have a positive over positive for my tangent. My tangent needs to be negative. So this is the point it has to be there. Okay. So I need to figure out what my x-coordinate is. Nope. It's √5. Yeah. Okay. Let me draw this a little bigger here. Think about it like this. This gives me a sine of this angle here, beta. I hate writing beta. Gives me that sine of 2/3. Why do I know it's over there? Because the tangent has to be negative, right? And in order for the tangent to be negative, either the x or the y, but only one of them has to be negative. I know my y-coordinate is positive because the sine is positive, which means my x-coordinate has to be negative. That's why it's in that quadrant. Positive y, negative x. Use the Pythagorean theorem to figure out what that length of that side is. X squared plus 2 squared equals 3 squared. And you end up getting square root of 5, but because it's in that direction, it's negative √5. So my cosine of beta is negative √5 over √5 over 3. And the tangent of beta is the y over the x, 2 over negative √5, which is negative 2 √5 over 5. Yes?
So if the sine is 2/3, doesn't that mean that the y-coordinate is also 2/3 then?
No. The sine, when you're given a fraction like this, I understand kind of I understand your question. we are not on the unit circle. If you're getting fractional values like this, the only values you're ever going to get from the unit circle are going to be pi over root 2 over 2, 1/2, root 3 over 2, 1, 0, that kind of stuff. If it's something else, you're setting up a triangle like this. And your denominator is your radius, and the numerator is either your y-coordinate or your x-coordinate if it's sine or cosine. Okay, does that make sense? Does that help a little bit? No. It's opposite over Jason, which would be 2 over negative root 5. But if you go back here, hang on, go back. What do we have here for our tangent? What do we have over here for our tangent? Y over x. Y over x. Y over x, 2 over negative root 5. Y over x. Do it as y over x. Okay.
How do you know what your your initial two options are? Like, how did you know it was like
okay, my sine is a positive 2/3. 3 is my distance from center, so it's always positive. The numerator 2 is my y-coordinate. Where do I have a y-coordinate of 2? I have 2 places where I can have a positive y-coordinate. Same thing on this one. I was given a cosine of negative 4. That means my x is negative because the denominator is how far away from the center that point is. The numerator is my x-coordinate for that point. Where do I have a negative 4? I can have a negative 4 for an x here, and I can have a negative 4 for an x down here. That tells me my 2 possibilities to begin with. I eliminated this one because the sign was also negative, which means my y is negative. If your cosine is negative, your x is negative. If your sine is negative, your y is negative. This is where both the x and the y are negative. Okay? Logic and reasoning. That's what you're going to learn in this class, whether you want to or not. Okay? Okay. Quotient identities. Okay? In trigonometry, you have your basic trig functions. The most basic trig functions are sine and cosine. Sine and cosine are your 2 basic trig functions. All the other trig functions are properties of sine and cosine. So you have 2 of them that are quotient identities. The tangent of an angle is equal to the sine of the angle over the cosine of the angle. So tangent t is equal to sine t over cosine t. You've seen tangent before. The cotangent of t is the cosine over the sine. It is the inverse function. It is the reciprocal of the tangent. So you could think of the cotangent as 1 over the tangent. That'll work too. Okay. Reciprocal identities. Cosecant and CSC is cosecant. Can an elephant drive a Cadillac? Cosecant. Secant, which is 1 over the cosine. Please, 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 do not get those 2 confused. Sine, cosecant is 1 over the sine. Secant is 1 over the cosine. Cos do not go together. And the cotangent is 1 over the tangent. Now, hopefully you remember from last year in Algebra 2 when you were using inverse functions that the inverse of the sine of t is not 1 over the sine of t. The only time that when something to the negative 1 power is not 1 over that something, is when you are dealing with inverse trig functions. 1 over the sine is not sine to the negative 1 power. They're not the same thing. On your calculators, you will see a little key. You'll have the sine of x. You will have above that sine to the negative 1 power. That is not the cosecant. Inverse trig functions, by decree, if nothing else. It's the only time that something to the negative 1 power is not that, because what it is to the negative 1 power is the inverse of that function. And you did use inverse trig functions in Algebra 2 when you were given a sine value and you had to find the angle. You did that last year. I am reminding you of that. That is an important fact to remember. Now, something else that you need to remember to do some of the things we're going to be doing here. Sine squared x is the sine of x squared. We do this out of convention. We do not write the sine of x squared because you got to be careful. Are we taking the sine of x squared, or are we taking the sine of x and squaring it? There's an important distinction you have to have, and by convention, this is what we do with our powers of trig functions. If we have a trig function raised to a power, we write the power on the trig function. But what we mean is we mean that trig function of whatever number, you take that whole thing to that power. So if I see tangent of epsilon, and I think that's epsilon, I'm not positive. I get confused on my Greek numbers, so whatever. This is the tangent of epsilon squared. Putting the power on the trig function. Putting the power on the trig function means we take the trig function of that value and then square it. It's by convention, you need to know that fact. This inverse sine of t does not equal 1 over the sine of t. Okay? Inverse trig functions are a whole different thing. That's why we have the cosecant and secant and cotangent, rather than writing them to the 1 power. We have 1 over the sine, that is the cosecant. Now, this next step is just the beginning. And I do mean just the beginning of simplifying trig identities. We will get really heavy into this. It may not be until next semester, but we will get heavily into trig identities. Okay, and simplifying them. These are basic simplification of trig identities. And here's what you do. I have the cotangent times the cotangent of t times the sine of t. I want to write this in simplest trig terms as possible. Your first step is to take anything that is not sine or cosine and rewrite it using those identities as sine or cosine. So the cotangent is what? Cosine over sine. So I rewrite this as the cosine of t over the sine of t times the sine of t. What did I do? I just rewrote the cotangent in terms of sine and cosine. Now what? The sines cancel each other out. Because remember, this is sine over 1. So what do I do? Those cancel out. What do I get? I get the cosine of t. That's my answer. These are equivalent. And technically, we've created a new trig identity. The cosine of t is the cotangent of t times the sine of t. We will never use that, but that's kind of what we have done here. And there are lots of trig identities, and we will work on simplifying a lot of them as time goes on. These are the simple ones. Same thing on the next one. Your first step, rewrite tangent is sine and cosine. Rewrite cosecant in terms of sine. That's your first step. Rewrite anything that is not in terms of sine and cosine in terms of sine and cosine. So I get sine over cosine times 1 over the sine. What happens now? Yeah. Omega. I'm going to call that omega. It's not really, but it's close enough. Okay. Cancel those, which leaves me with 1 over the cosine. Now here's a problem. I don't want fractions for my final answer. What is 1 over the cosine? Secant. So this is the secant of omega. Okay? Okay, remember, first thing I'm going to do is rewrite things that are not in terms of sine and cosine in terms of cosine and sine. So I have cosine squared, I have sine squared, I have tangent squared. Rewrite the tangent squared in terms of sine and cosine. Do that first. And if the tangent is sine over cosine, tangent squared would be sine squared over cosine squared. Yeah, I know. Now what? Cancel out the cosines, which means that I have sine squared, and I do believe that is actually epsilon, sine squared of epsilon. And how many sine squareds do I have?
2.
I have 2 of them. I love doing trig identities and simplifying them. These are literally just scratching the surface. It will get much more complicated as we go along, and we will work on them. And there are tricks that I will show you as we go along. Okay. Now, so like I said, these will get much more complicated. When we get to them, I will show you tricks and tips on how to simplify them, how to change your identities. There are lots of tricks to them. I look at it as a puzzle. I want to get from point A to point B by making little changes along the way. Okay, last one. Using your unit circle. Find the exact values of sine, cosine, and tangent of the angle without a calculator. Some of these are right on your unit circle. Some of these, you have to find the coterminal angle that they will match up with to get your sine, cosine, and tangent values. So using your unit circle, Go through, find the sine, cosine, and tangent of every one of these. Okay, so let's finish this off. 7 pi over 6 is a value on your unit circle. Okay, so you get negative 1/2 for the sine, and you end up with negative √3/2 for the cosine, and that gives you √3/3 for the tangents. Seven pi over 6 is right here. Okay. That one is a direct value. That's okay. Now 7 pi, here's what's really nice about 7 pi. Any integer values of pi will either be 1, 0 or negative 1, 0. Count around. 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 6 pi, or sorry, 5 pi, 6 pi, 7 pi. So 7 pi is the equivalent of pi. Any odd integer of pi is the equivalent of pi. Any even integer of pi is 2 pi. Whether they're positive or negative, it doesn't matter. Yes? Because it would be, for this one here, it would be negative 1/2 over negative √3/2, right? Which is 1 over √3. And then what do? Rationalize the denominator. Multiply it by √3/3. Because when you have the same denominator for a compound fraction, you just have the numerators. 1 over 2, √3/2 is just 1 over √3. So for this one, sine of pi, 0, negative 1, and the tangent is 0. Your tangent can be undefined. Your tangent is undefined at pi over 2 and 3 pi over 2. Because the cosine is 0, so your denominator would be 0 in those. So it is possible for the tangent to be undefined. It is also possible for the secant and cosecant to be undefined. Okay. And we'll talk about that more next time, I think, actually. Okay, sine of 7 pi over 3. 7 pi over 3 is the equivalent of 1 pi over 3. And so you just have to have those. √3/2, ladies. 1 over 2. And the tangent's √3. And then 7 pi over 4 is a value on your unit circle. And anything over pi over 2 is, for the sine and cosine, it's √2/2. Tangent's always 1. It's whether they're positive or negative. 7 pi over 4 is over here, so the cosine's positive, sine is negative. Negative √2/2, √2/2, and this would be negative 1 for the tangent. Yes? Okay, so once again, you need to find the coterminal angle. Is the denominator more than twice the numerator? Is the numerator more than twice the denominator? Yes. So subtract twice the denominator. So subtract 6 pi over 3. And you end up with 1 pi over 3, which is pi over 3. Questions? Okay.